Dear students, welcome again to HomeLearns classes. In this class, you will study about sum and difference of two angles of trigonometric functions. That how the two angles or the two numbers in the trigonometric functions can be subtracted and can be added. So we shall derive expressions for trigonometric functions of sum and difference of two numbers, two angles, that is numbers, maybe angles, and the related expressions. And the result in this connection will be trigonometric identities, and all those becomes the trigonometric identities. Trigonometric identities is very important to learn. It is the heart of the trigonometric identities, and these identities are very important to solve all of the questions related to trigonometry. So please repeat this video again and again, watch this class again and again. If you learn all these 22, 23 identities, then you will completely understand the trigonometry and you can solve any of the questions easily. So be attentive. Now, trigonometric functions. As we know that we have the two identities, already two identities. What are two identities? Identity one is, number one identity is sine minus x is equal to minus sin x. Another identity is cos minus x is equal to cos x. You have studied these identities in your previous classes. Let's prove more identities. Identity number 3. This is the most important identity, and if you solve this identity and you learn how to prove this identity, then the remaining identity will become a play for you. Cos x cos y minus sin x sin y. How you would prove? First of all, let's consider a unit circle. Unit circle means circle having one unit radius. Circle having one unit radius. Through the origin, I will draw a circle with center at its origin. This is the center. This is the x-axis, y-axis, x negative, x dash, y dash, means y negative. Let, first of all, let x is an angle. What we have to draw here? Here we need three things: x, y, and x plus y. If we have all these three things, then we can calculate cos x plus y, cos x, cos y minus sin x, sin y. First of all, let's consider an x. X is an angle. This is the x angle, and these are the coordinates through the origin for x. Let's consider it as a P1. P1 is x numbers for x coordinate x angle. It means cos x sine x is the coordinates for this. And this is unit circle, hence it is equivalent to x. Hence it is equivalent to x. Now let's consider more in the y section. Y. Let's consider it a P2 point. P2. This is the y. Y is from here to it. Now hold, this unit becomes x plus y. X plus y. Now P2 will be, this is the P2, and the P2 will be for x plus y cos x plus y sin x plus y. These are the P2 points. Now draw a negative angle from here. Y. This is a negative angle. And this is the negative, and let's draw a point P3. This is the negative angle P3. So P3's coordinate would be cos minus y sin minus y. And this is the point P4. It is at the origin of the circle. Its point would be 1, 0. So there are the four coordinates P1, P2, P3, P4. We have the four coordinates, and all four coordinates are cos x, x angle. This is the x number. This is the y number, or minus y number, x plus y number, and 1, 0. Now, from this figure, what we reach on the conclusion that P1 there becomes a triangle P1OP3. This is the triangle P1OP3, and there becomes another triangle, that is the P2 P2OP4. There becomes two triangles, and these triangles are congruent triangles because of the rules of side angle side, SAS. You have studied in your previous classes also. It means that this theta angle would be the same. This theta angle would be the same of this angle, or the side would be same as it is. Now we will prove it also that is this congruent. Therefore, it is congruent. Therefore, P1, P3 is equal to P2, P4. P1, P3 is equal to P2, P4. How? We will prove it. Now let's P1, P3 by using the distance formula. What the distance formula states? Distance formula. Distance formula states that if you have 2 points, distance between the 2 points, like if you have x1 y1 and x2 y2. So what is the distance formula? Distance formula is x2 minus x1 square minus y2 minus y1 square. This is the distance formula. This is the distance formula. Based on this, we will calculate P1, P3. For easiness of P1, P3, we can remove this square root, and here we can write it as a P1, P3 square. By removing this P1, P3 square, and P1 is cos x sin x, x1 is cos x sin x, and cos minus y sin minus y. So cos x means x2 cos x minus cos minus y whole square plus sin x minus sin minus y whole square. As we know that cos minus y is equal to cos y. It is the identity. The second identity shows, and sin x minus sin minus y is the minus, and minus sin y according to the first identity, and cos x minus cos y whole square plus sin x minus minus plus sin y whole square. And if we apply the formula of a minus b whole square a plus b whole square, then it becomes cos square x plus cos square y minus 2x cos y plus sin square x sin square y plus 2 sin x sin y. Because as we know that sin square x plus cos square x is equal to 1. So we can write it as this and this as 1 plus this and this again 1. And this becomes minus 2 cos y. 2 is the common. Cos x cos y plus sin x sin y. Or you can state it as 2 minus 2 cos x cos y plus sin x sin y. That's the P1 P3 square. Now similarly do it for P2 P4 square. P2 P4. What is the P2? Let's write down here so that you would not be confused. Cos x plus y, P2 is cos x plus y, sin x plus y, and P4 is 1, 0. So x2 minus x1 means 1 minus cos x plus y whole square plus 0 minus sin x plus y whole square. Okay, 1 minus 2 cos x plus y with the help of the simplification, cos square by the formula cos square x plus y plus a square 0 plus b square sin square x plus y and 2ab. So that again we will apply the formula. Now it is cos square x plus y sin square x plus y, it becomes 1 because of cos square x plus sin square x y is equal to 1. Cos square x sin square x is equal to 1. 1 minus 2 cos x plus y plus 1, and it becomes 2 minus 2 cos x plus y. 2 minus 2 cos x plus y, because P1 P2 is equal to P2 P4. P1 P3 is equal to P2 P4. Hence, we will write 2 minus 2 cos x cos y minus sin x sin y is equal to 2 minus 2 cos x plus y. 2 and 2 cancel, minus and minus cancel, 2 is again cancel, and we reached on the conclusion that cos x plus y is cos x cos y minus sin x sin y. So I hope you understood the proof of this identity very well. Next identity is identity number 4. Cos x minus y is equal to cos x cos y plus sin x sin y. If we replace y with minus y in the above identity, in this identity, if we replace y by minus y, then it becomes cos x plus minus y. It is the same. Cos x cos minus y minus sin x sin minus y. Cos x cos minus cos x, cos minus y is cos y, minus sin x minus sin y, and minus minus plus cos x cos y plus sin x sin y. You can prove it easily. Or with the above, where we have taken the x plus y, you can take x minus y. Identity number 5, you have to learn these also. Cos pi by 2 minus x is equal to sin x. Just like according to identity 3, or this becomes the identity 4. So according to identity 4, cos pi by 2 minus x is cos pi by 2 cos x plus sin pi by 2 sin minus x, sin minus x. Sin pi by 2. Oh, so minus sin pi by 2 minus sin minus x. Cos pi by 2 is 0, minus sin pi by 2 is 1, minus sin x, minus plus, and it becomes sin x. Cos pi by 2 minus x is equal to sin x. So each and every identity is related to everyone. If you learn 2, 3, or 4 identities, then you can easily solve remaining identities also. Now identity 6, 10. Sin pi by 2 minus x. Sin pi by 2 minus x is equal to cos x. Using identity 5, we have sin pi by 2 minus x is equal to cos x, and we have cos pi by 2 minus pi by 2 minus x, and it is cos minus x, and it is cos x. That is the identity number 6. Have also been proved using identity 5, using identity 4, using identity 3. You can prove all the remaining identities. Now one more identity. Our previous identity would be for cos x plus y. Remaining identity, next identity is for sin. Sin x plus y is equal to sin x cos y plus cos x sin y. So sin x plus y we can written as cos pi by 2 minus x plus y plus cos pi by 2 minus x minus y. We can write this using the above properties. Cos pi by 2 minus x is again cos x. Cos pi by 2 is 1, or we can write it as cos pi by 2 minus x cos y plus Sine pi by 2 minus x sine y. It becomes cos pi by 2 minus x is equal to sine x. Hence it becomes sine pi by 2. We know that this is the cos x. Cos pi by 2 minus x is again sine x cos y, and this is cos x sine y minus cos x sine y. That's the identities. And one more identity, sine x minus y is sine x cos y minus cos x sine y. You can use, if you replace minus y by minus y in the identity 7, so you can get the result. And in about 3, 4, 5, 6, 7, 8, in all the other identities, if you put x and y values, suitable x and y values, then you can reach on the following results also. Cos pi by 2 plus x is equal to minus sine x, and sine pi by 2 plus x is equal to cos x. Cos pi minus x is equal to minus cos x. Sine pi minus x is equal to sine x, and cos pi plus x is minus cos x. Sine pi plus x is minus sine x. Sine 2 pi minus x is equal to minus sine x. So you can get the result all for these, and if you have these identities, then you can obtain the results for tangent, cotangent, secant, and cosecant. So till now, in this class, only these identities are to be learned here. In the next section, I will do for you the remaining identities. Keep learning the identities. Don't forget. All these must be remembered to you. Make a note of this in front of your study table and learn this. You will solve trigonometric questions within a day. Thank you.